Auzubillahi minash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum, dear students. Today we are going to start a new lecture which is related to phase relationships of soil, or sometimes it is also known as weight volume relationships of soil. So first we will start with understanding the three-phase assumption, which is that soil contains solids, water and air if it's partially saturated or unsaturated soil. Then we will study and learn about fundamental definitions such as water content, void ratio, porosity, degree of saturation, air content, unit weight, specific gravity, density, relative density, and we will derive few phase or weight volume relationships. At the end of today's lecture, we will solve few problems related to those relationships. So starting with the three-phase assumption, soils generally contain soil grains, water and air, which are known as the three phases. Now the relative proportions of these three phases play an important role in the engineering behavior of the soils. We also discussed about the void spaces. These void spaces may contain water and air, and in dry condition water will be missing, only air will be there, and fully saturated condition air will be absent and water will be present there in the void spaces. Now if there is no water in the void space, that is a dry soil. If the void spaces are filled with water, then we can call that as fully saturated soil. Moist or partially saturated soils having three phases like air, water and solids. What we are trying here, we are idealizing the real soil sample. So it is important in all geotechnical engineering works to establish relationships between the weight of air, weight of water, weight of solids, where the weight of air is negligible, it is taken as 0. So if we are having weight and volume relations, that will affect the engineering behavior of soils. Therefore, a geotechnical engineer must understand and learn about the phase relationships or weight volume relationships of each phase. This is a real soil sample having solid particles present in here, void spaces. If they are filled with water, that would be fully saturated soil. Here as well. So these void spaces, if they are filled with water, you can call that as saturated soil. If it's filled with air, then it's dry soil. So we can idealize this soil having the total weight, and we can also idealize that as total volume in terms of a phase or block diagram, where we are saying that, for example, this is weight of air, which is negligible, equal to 0. Weight of water from here till here, that is weight of water, and weight of solids. So you can divide this weight in weight of solids and weight of water, and that is the total weight. Now the total volume can also be divided into volume of voids, which means that you can divide that in volume of air and volume of water. Air and volume of water. Now the volume of solids here and if we add the volume of voids, that will form the total volume of the soil mass. So this is the real soil sample, and this is the idealization to draw or to understand the relationship between the weights and volume of these phases, for example, the air, water, and solids. Now, why it's important? It's important in understanding the engineering behavior of soils. Now we can write the explanation which is made in our previous slide in an equation form, that the total volume can be divided into the volume of solids and volume of voids. Similarly, we can write the volume of voids as the volume of water plus volume of air. Phase diagram is given here as well, where the total volume is divided into volume of voids and volume of solids, and then the volume of voids is divided into volume of air and volume of water. Similarly, the weight of air and weight of water, if you add them, that will form the total volume. So if we add the weight of voids, basically it's weight of water and weight of solids, that will form the total weight of the soil mass. So please note down this equation and this equation as well. It's important from the exam point of view. Now we need to understand a few fundamental definitions between the weight and volume. So all these weight and volume relationship needed in soil mechanics or in geotechnical engineering can be derived from the appropriate combinations of fundamental definitions, and they are water content, void ratio, porosity, degree of saturation, air content, unit weight, specific gravity, density, relative density, and so on. Now, starting with the water content, it's pretty much simple that the water content is defined as the ratio of the weight of water to the weight of solids. For example, we can draw three-phase diagram. This is solids, this is water. For example, if we are having weight of air, which is negligible, it's equal to 0. Weight of water, and this one would be weight of solids. Now, if we are comparing the weight of water with the weight of solids in a soil mass, that is known as the water content. And the water content is determined by weighing a sample of the soil and then drying the sample in an oven at a temperature of 105 till 110 degrees Celsius and reweighing it. A drying period of 24 hours is normally adequate for most soils. Void ratio is defined as the ratio of the volume of voids to the volume of solids. If you again draw the three-phase diagram, so this is the volume of solids, this is the volume of water, and this one is the volume of air. Now, if you combine this is the volume of voids. If you are comparing volume of voids with the volume of solids, that would be equal to the void ratio. And if you are comparing the volume of voids to the total volume, how many voids are present in the total volume of this soil mass, that is known as porosity. Void ratio and porosity will not change if water is added or removed from a soil, because the volume of voids include both the volume of water and air. These are unitless quantities presented in decimals. So it's unitless quantities. Now, the degree of saturation, and if we draw again the phase diagram, this is the volume of solids, this one is the volume of water, this one is volume of air. If you combine them both, this is volume of voids. We are having total volume. What is the volume of water present in the volume of voids? That would be known as the degree of saturation. Now, the degree of saturation can range between the limits of 0 till 1, or we can say 100% for a fully saturated soil condition. Air content is defined as the ratio of volume of air to the volume of voids. If you are comparing volume of air and volume of voids, that is known as air content, or how much air is present in the voids. So it is saturated, S is equal to 1, and the air content will be equal to 0. Unit weight is simply defined as weight per unit volume. Did you know about the weight and the volume relationship? The weight of the soil and the volume of the soil, that is known as unit weight. Unit weights are of various types. For example, bulk unit weight or moist unit weight, dry unit weight, saturated unit weight, submerged unit weight. Now, what is bulk unit weight? Bulk unit weight is defined as total weight of a soil mass per unit volume Dry unit weight is the weight of the soil solids to the total volume. You can write total volume as well if you want. And in dry case, it would be the weight of solids compared to the total volume, because the dry word is used, which means all the moisture has been dried up. So if S is equal to 0, no water particle is present in the words, that is dry soil. Dry unit weight will not be affected if water is added or removed from soil, because it uses the weight of soil solids. So you can clearly see here weight of soil solids are used. Therefore, the dry unit weight value will not be affected if water is added or removed from the soil, because it uses the weight of soil solids, whereas the total volume already includes the volume of voids, which later might be filled with water as well. Now, when the soil mass is saturated, its bulk unit weight is called the saturated unit weight. The saturated unit weight is the ratio of the total weight of a saturated soil mass to its total volume. And if S is equal to, our degree of saturation is equal to 1, all the voids are filled with water. Submerged unit weight is defined as submerged weight of soil to total volume. The weight of the solids minus the weight of water displaced by the solids divided by the total volume. Or we can also find out the submerged buoyant or effective unit weight using this equation or using this equation. But this equation is predominantly used in technical engineering and foundation engineering. Now, among the bulk unit weight, dry unit weight, saturated unit weight and submerged unit weight, the order of decreasing unit weights are: the saturated unit weight is greater than the bulk unit weight, and the bulk unit weight is greater than the dry unit weight, and the dry unit weight is greater than the submerged unit weight. There is another definition and a term which is also used in deriving the phase relationships. That's the specific gravity, and it's defined as the ratio of the unit weight of a substance to the unit weight of pure water at 4 degrees Celsius. And that value is equal to 1 gram per cubic centimeter if we are dealing in grams and centimeter, and if you are dealing in kilonewtons and meters, then the value of 9.807 should be taken. Specific gravity can also be defined as the ratio of the weight of the soil solids to the weight of the water, and you can write gamma S as Ws divided by volume of solids. To replace that, you can simply write this equation in this form. Now, the mass specific gravity can be defined as the ratio of bulk unit weight of the soil to the unit weight of water. Now, if we replace the word weight by mass in all the various types of unit weight definitions, for example, dry density is the mass of solids to the total volume, then that is known as the dry density of soil. and ms would be the mass of soil solids, and rho d would be the density of soil. Relative density is defined as the ratio of the difference of void ratios of cohesionless soil in its loosest and the natural state to the difference between the void ratio in its loosest and densest state. So this is the equation for the relative density. E max is the void ratio of the soil in the loosest state, which will give us the rho minimum or minimum density of the soil. E minimum is the void ratio of the soil in the densest state, which will give us the maximum density, and E is the in situ or the field void ratio of the soil, and dr is the relative density, usually given as a percentage. Now, relative density determines the compactness of the cohesionless soil. It is used to indicate the in situ denseness or looseness of the granular soil. The values of relative density may vary from a minimum of 0% for very loose soil to a maximum of 100% for very dense soils. Now, in place or in situ soils seldom have relative density less than 20 to 30%. Compacting a granular soil to a relative density greater than about 85% is also a very difficult task. Now, the background for the phase relationships has been given. Now we are moving towards deriving few phase relationships. For example, this weight of soil can be divided in the weight of water and weight of solids, and the weight of water is equal to the water content into specific gravity and gamma of water, and the weight of solids is equal to the specific gravity into unit weight of water. These equations are also given here. Example, if we are deriving this equation, that weight of solids divided by the unit weight. Now, the weight of water can be written in the form of water content into the weight of solids, and we already know that weight of solids can be equal to Gs into gamma of W. Now, these equations are valid when we take an assumption that volume of solids is equal to 1 and the volume of voids equal to E, and the total volume is equal to 1 plus E. Here, the volume of water will be equal to the water content into specific gravity, and we can further write that equation of weight of water into the water content, specific gravity, and unit weight of water. Now we can also derive further equations for the void ratio and porosity. For example, we already know that the volume of voids is the void ratio is equal to volume of voids to the volume of solids, and volume of voids, solids can be written as the total volume minus volume of voids, and if we divide the volume of voids divided by the total volume, and we also divide this term by volume, total volume, we'll get the 1 here, and volume of voids to the total volume, volume of voids to the total volume, that is equal to the N, which is porosity. We can also write a relationship between the void ratio and porosity, and that is equal to E divided by 1 plus E. These are very important equations or relationships which might be helpful solving problems during an exam, quiz, or an assignment. In another relationship, unit weight and water content are used. Unit weight, we already know that it is weight per unit volume, our total volume, so the weight is equal to weight of solids plus weight of water. And now you can take that weight of solids common, so you will get the weight of water divided by weight of solids here, and we already know that is equal to the water content, so we can write that the unit weight is equal to 1 plus W divided by total volume. So it's also an important relationship. Now the relationship of unit weight, tri-unit weight and moisture content can be written in this form. There is another famous equation as E is equal to WGS. S is the degree of saturation, E is the void ratio, this is the water content, this one is the specific gravity. Now if you want to derive this equation, we can write that as the water content is equal to weight of water compared to the weight of solids, and that water content, this weight of water can be written as unit weight of water into the volume of water, or you can say that it's coming from the weight per unit volume. And if you are talking about unit weight of water, it's weight of water divided by volume of water, and the weight of water equal to gamma of water into volume of water. So that's what's written in here. And if you can further simplify that the water content is equal to the unit weight of water into the degree of saturation and into the volume of voids, that expression can be taken from here. And the specific gravity is equal to the unit weight of solids to the unit weight of water. And further, if we simplify, we will come up with the equation which is weight is equal to S into volume of voids divided by GS into VS. Now water content is equal to SE divided by GS, or you can write this form as well. Now if you want to derive a relationship between the degree of saturation, void ratio, unit weight, bulk unit weight, specific gravity of solids, we can also derive a relationship from the weight and volume, and further dividing that weight of water, weight of solids, and then dividing it by the weight of the volume of solids, further simplifying it, and then multiplying and dividing it by the volume of voids here, and using those tiny relationships which we derived previously, we will come up with a new relationship, which is bulk unit weight is equal to unit weight of water, S which is degree of saturation, E is the void ratio plus GS divided by 1 plus E. That's also an important relation. Now if we want to derive a relationship between the water content, void ratio, unit weight of water, bulk unit weight of soil, and specific gravity of soil solids. So we can start from the weight and volume, and then we can write in terms of the weight of water and weight of solids. Again, we start the deriving this or simplifying this equation. Instead of unit weight of solids, we are writing it here gamma of solids is equal to GS into gamma of water, and that's what it's written in here. And if you divide it by volume of solids, so this term will become 1, and volume of voids divided by volume of solids will make this term as E, or void ratio. And we already know that specific gravity is the weight of solids divided by gamma of water or into volume of solids, and this volume of solids can be written as this form: weight of solids divided by gamma of water into GS. And if we further simplify, at the end we will come up with the bulk unit weight, which is equal to unit weight of water into specific gravity 1 plus water content divided by 1 plus E. Now previously we got a relationship between the unit weight of water as EGS. Now here we got a relationship between the unit weight GS 1 plus WO divided by 1 plus E. Now there are several other relationships or various forms of relationships for the unit weight or the bulk unit weight, dry unit weight, saturated unit weight. For moist unit weight or bulk unit weight, relationship between water content, specific gravity and void ratio is this one. Degree of saturation, specific gravity and void ratio, the relationship is this one, which we already derived. There are other relationships, or more relationships are also available between these terms for the moist unit weight, dry unit weight and saturated unit weight. Now let's start with a problem. Our problem number 1: a moist sand sample has a volume of 450 cubic centimeter and a wet mass of 786 gram. This is a moist sand sample volume. The particle density is 2.65 gram per cubic centimeter and the dry mass is 731 gram. You determine the void ratio, porosity, percentage, water content and the degree of saturation. Now the mass of water can be easily find out from the wet mass, subtracting the wet mass, which is 786, from the dry mass, and that's equal to 55 gram. Now the volume of water, mass of water divided by the density of water, and we already know that the density of water is equal to 1 gram per cubic centimeter. Now the mass of solids equal to 731 gram, and the volume of solids will be equal to mass of solids divided by the density of the solids, and the density of the solids is given 2.65, this one. Now the volume of air we can easily find out by subtracting the volume of solids and volume of water from the total volume, and this is the volume of solids and this is the volume of water, and if you subtract the water and solids we will be left with the volume of the air. Now the volume of voids if we add the volume of water and volume of air is this much, and the volume of water is this one, and if we add these two, we will get the volume of voids. Now we can easily find out the void ratio, because we already know that the void ratio is equal to volume of voids divided by volume of solids, and that is 0.63. Porosity is volume of voids to the total volume. The volume of voids is this one, and the total volume is 450. From where we got 450, we got 450 moist. This is the total volume of the moist soil. Water content we can find out from the mass of water divided by the mass of solids, and that is 7.52%. Degree of saturation is equal to volume of water in volume of voids, and the volume of water is here, bring it here, and we need to compare it with the volume of voids. Volume of voids is this one, and the degree of saturation is 31.4%. So that's how you can solve and find out different properties. Another example, in its natural condition, a soil sample has a mass of 2,290 grams and a volume of 1.15 into 10 raised to the power minus 3 cubic meter. After being completely dried in an oven, the mass of the soil is 2035 gram. The value of specific gravity for the soil is 2.68. Need to determine the bulk density, rho E, unit weight, water content, void ratio, porosity, degree of saturation. Now the bulk density can be found out using the equation of mass per unit volume. So we already know that it's 2.290 kilograms or 2290 grams. So, and the volume is 1.15 into 10 raised to the power minus 3. So it's 1990 kilogram per cubic meter or 1.99 megagram per cubic meter. Now we already know that unit weight is equal to weight per unit volume, and that weight is equal to mass into gram divided by volume. Therefore G is the mass into gravity, that is 9.8, and 19,500 Newton per cubic meter or 19.5 kilonewton per cubic meter will be the unit weight of the soil. Now the water content, if we compare the mass of water with the mass of solids, we can easily find out the mass of water and we can compare it with the mass of solids, and that is 12.5%. We already derived an expression for the bulk unit weight, relating the unit weight of water, specific gravity, water content, and the void ratio, and the void ratio is equal to 0.52 because unit weight of water is 9.81, GS is 2.68, the water content is 12.5%, the bulk unit weight is 19.5. So we can easily find out the void ratio and we can calculate that. Porosity can be found using this expression, this relationship, and it's 34. The degree of saturation, as I mentioned earlier on, as E is equal to WGS. So S is equal to W into GS divided by, is the void ratio. We already find out the void ratio, the water content, and the specific gravity. We can find out the degree of saturation, which is equal to 64.5%. Now we need to calculate the dry unit weight, the saturated unit weight, and the point or the effective unit weight of a soil having a ratio of 0.70 given, and the value of GS, specific gravity, is given. We need to calculate the unit weight or the bulk unit weight, water content at a degree of saturation of 75%. We need to find out the water content at 75%. S is equal to 75%. Our degree of saturation is equal to 75%. Now different approaches can be used we can solve it for porosity. N is equal to E divided by 1 plus E, and we will come up with the porosity first. The porosity is equal to, or N is equal to 0.412. Now we already know that E, which is the void ratio, is equal to volume of voids divided by the volume of solids, and porosity is equal to volume of voids to the total volume. Now for 1 unit volume of soil, volume of voids will be equal to 0.412. Now the total volume is equal to volume of solids plus volume of voids, and we know that volume of voids equal to 0.412, and the total volume is taken and assumed as 1. So the volume of solids will be equal to this much. This would be volume of voids and volume of solids will be equal to 0.588, and if you sum these two, that will give you the total volume. Now we can find out the weight of solids as well, and we know that weight of solids is equal to GS into VS into gamma of water. GS is 2.72, this is specific gravity. VS is the volume of solids, that is 0.588, and unit weight of water is 9.807, and 15.673 kilonewton would be the weight of solids. And if you divide it by the volume, which is 1, that will be the unit weight or the dry unit weight of the soil solids. If you want to find out the bulk unit weight, we can use 9.807, GS is 2.72, water content for dry unit, the water content should be equal to 0, and the void ratio, we already have it, 0.7 is the void ratio, and we can come up with the dry unit weight, because we are taking that water content equal to 0. Similarly, we know that the bulk unit weight is equal to the unit weight of water into degree of saturation into void ratio plus specific gravity divided by 1 plus E for saturated soil. S will be equal to 1, and the saturated unit weight, you can use this equation where unit weight of water 9.8, E is the void ratio, GS is the specific gravity, and E is the void ratio. So the gamma saturated would be equal to 19.73 kilonewton per cubic meter. We can find out the effective unit weight or the point unit weight from the relationship of subtracting unit weight of water from the saturated unit weight, and that would be equal to 9.92 kilonewton per cubic meter. From this relationship, SE is equal to WGS. We need to find out now. For water content, we know the relationship is this much. What else? At the end, we need to find out water content at a degree of saturation of 75%. Okay, so unit weight. Okay, we need to find out calculate also the unit weight and water content at a degree of saturation of 75%. So the water content is known here from this relationship. Now we need to find out the unit weight. This is unit weight here. The space shouldn't visit here. Okay, so the bulk unit weight is unit weight of water, SE plus GS, 1 plus E. So you can use the previous equation, but now we need to put 0.75 for the 75% of degree of saturation. And we will calculate the unit weight of, or the bulk unit weight at 75% degree of saturation. This is 18.72, and the water content at this saturation level is 19.73%. In problem number 4, it is stated that a container of volume 2.83 into 10 raised to the power minus 3 cubic meter weighs 9.8 Newton. Now dry sand was poured to fill the container. The container and the sand weigh 52.3 Newton. We need to calculate the void ratio and porosity. Now describe the soil condition of the soil, loose or dense, assuming the specific gravity equal to 2.7. Now we talked about the relative density in our earlier part of this lecture. So here you can see that the description of the coarse-grained soil based on relative density and porosity. For 0 to 20% of relative density, that soil is known as very loose, or it will be having 80 to 100% of the porosity. From 40 to 70% of relative density, that will be medium dense or firm soil. It will be having porosity between 30 to 60%. For 85 to 100 relative density value or percentage, that would be very dense soil, and it will be having porosity less than 15%. So unit weight of dry sand can be find out from the weight of sand plus container. This much weight of container is 9.8 Newton. Weight of dry sand or weight of solids, we can simply subtract 9.8 from the 52, and that would be in newtons and kilonewtons. Now the dry unit weight, we can use this equation, weight of solids to the total volume. It would be 15 kilonewton per cubic meter. We already know that the dry unit weight is weight of solids divided by volume, and we derive this expression. Now we can rearrange this relationship and we can solve it for E. GS is known, gamma of water is known, gamma T is known here, which is the unit weight, the dry unit weight. So we will come up with the E value, which is the void ratio. And once E is known, we can use this relationship to find out the porosity. And the soil type, when the porosity is 43%, the sand will be in medium dense or firm condition. In the last problem, the void space in a soil sample consists of 80% of air and 20% of water. The void space, they are talking about the void space. This is the volume of solids, volume of water, volume of air. So 80% is air, 20% is water, and the unit weight dry unit weight is given and the specific gravity Gs is also given. Now we need to determine the water content. So we already know that gamma T, which is the dry unit weight, is equal to Gs into gamma of water 1 plus E, and if we rearrange this equation, E would be equal to EGS gamma W divided by gamma T, and that Gs is 2.7, gamma W is 9.8, 15.7 is the gamma T minus 1, E is this much. Now solving for the water content, we need to use this equation SE into W into Gs, and W is SE divided by Gs. Now we need to find the degree of saturation, as this is the only unknown value apart from the W. Now the degree of saturation is the ratio of the volume of water to the volume of voids. Since the volume of water is 20% of the void volume, the degree of saturation is 20%. Now S is equal to 0.2 and the water content is equal to 5.1%. Thank you very much everyone, and I hope you are enjoying my videos. Please kindly like, share and subscribe to my YouTube channel. Assalamu alaikum and Allah Hafiz.